In this lecture, I'll be talking about pipes, which are one of the most useful command line features in Linux. Pipes are used in countless ways and are just about everywhere. The Unix and Linux design philosophy is to have many small utilities that perform very well just one dedicated function without needless functionality. In Linux, you write programs to do one thing and to do it well, and then you make them work together. Let's take a look at this image. Every command or program we run has three data streams connected to it. stdin, or standard input, which represents data fed into the program or the data the program is working with. stdout, or standard output, which is data printed by the program by default to the terminal, and stderr, or standard error, for error messages and also defaults to the terminal. Using the pipe symbol, which is a vertical bar, we can connect two or more commands at a time. This supports the initial Unix philosophy of chaining programs together to complete complex tasks. So a pipe lets us send the output of one command as input to another one. Piping and redirection are the means by which we may connect these streams, input, output, and error, among programs and files to direct data in interesting and useful ways. Let's take a look at this mechanism. I'm running ls -l capital S h /etc. The command has listed all files in the etc directory sorted by size in human readable. There are lots of files, and I finished up seeing only the last ones, the smallest files. The largest ones are at the beginning, and I have to scroll to see them. What I could do is connect the ls command with the head command. Using a pipe, I'll send the output of the first command, which is ls, as input to the second command, which is head, like this. Pipe, head. And we are seeing only the head, or the first 10 files of the output, and those are the largest ones. It's common and recommended to add a white space before and after the pipe symbol. But that's not, however, mandatory. This isn't an error. We can pipe together as many commands as we wish. In the next example, I'll filter and display only the 20th file of the output. It's just an example to see how it works. So head -n20, pipe, tail -n1. This is the 20th line of the output. Let's take a closer look. The output of the ls command becomes the input for head, which will display the first 20 lines. These first 20 lines, which are the output, are fed as input into the next command, which is tail, and the tail command will display only the last one, which is in fact the 20th line of the output. So the pipe takes the output from one command and uses it as input for another one. And the last example, I want to find out how many authentication failures took place. There isn't such a command in Linux, so I have to build my own using pipes. First, using cat, I'm displaying the entire file. Cat var log auth.log. This is the file where authentications are saved. This is the file. I can also add a -n to see the line numbers. Then, the output of the cat command will be given as input to another command called grep. Grep is a command line utility that searches for a string inside a file or a text and displays the lines containing the string. So pipe grep -a and the string I'm searching for. Authentication failure. And there are some matches. There are more lines that contain the string. These are all authentication failures. And finally, I want to see how many lines were found. The output of the grep command will be given to another command called wc, which counts how many lines were given. So pipe wc minus l. And it returned 6. So there were 6 authentication failures saved in the log file. Let me tell you a few words about wc, which is short for word count. It brings new line, word, and byte counts for each file. wc etc password. There are 48 lines, 83 words, and 2825 characters in that file. This command is used to get different statistics. I've just found out that there are 48 accounts on the system. If you only want to see the line counts, then use option -l, wc -l etc group. There are 76 groups on the system. wc -w will display only the word counts and -c only the character counts. So wc -w, USR, share, dict, American English. This is a standard dictionary that you'll find on Ubuntu. And there's this number of words in this American English dictionary file. Let's see how many characters are in the file. And there are almost 1 million characters in the file. You can also use it with a pipe. Let's see how many users are logged in. Who is displaying? The logged in users. So who? Pipe wc -l. There's only one user logged in. One of the main purposes of piping is filtering. You use piping to filter the contents of a large file to find a particular string or a word, for example. Note that when you use a pipe, you are not running a single command, but each command in the pipe starts. So, in this example, in this one, I've started 3 processes, each command starting a process: cat, grep, and wc. Take your time to exercise and deeply understand how pipes work, because this is a key concept in Linux and you'll find it everywhere. The pipe is one of the most used shell features.